Hey everyone, it is September the 2nd, 2022. Welcome to another Open Cluster Management Community Meetings. Today we have two topics. We have Yu Chang, who's going to talk a little bit about the standalone Open Cluster Management mode, and then later Q Chang is going to talk about the ClusterAPI integration. So without further delay, Yu Chang, do you want to get started? Thanks.
Hello?
Yes, we can hear you. Hello. Yep, we can see your screen.
Okay, let's get started. Hi, I'm Chen. Today, I will introduce my recent work, Standalone OCM Control Plane. This prototype is related to issue 43 in our GitHub repo OCI. Now let's get started. You must have seen these two pictures before. I found them from OCM website and Kubernetes website. Before today, if we want to have a hub, we need to start all necessary components as deployment on Kubernetes cluster. But sometimes we just use hub to manage other clusters, meaning that we don't deploy our applications on it. So can we build a lightweight hub to replace all of those pods running on a cluster? Maybe in some scenario. Surely we can, and here I am. As you can see, the standalone OCM control plane is just combined by two main parts. One is its API server, like the kube API server in Kubernetes cluster. The other is ETCD. For the API server, first we installed necessary API groups and Kubernetes controllers. The OCM CRDs, OCM controllers, and OCM webhooks. To build up this control plane, we need to do the following 7 steps. I will give you a simple explanation. First step, disable some enable by default API groups in the Kube API server. Unlike Kubernetes API server, there are some APIs we don't need in our standalone control plane, such as apps, auto-scaling, batch, and so on. Second, install necessary Kubernetes controllers. As we know, in a Kubernetes cluster, the controllers are running in the kube controller manager. For our control plane, we just need few of the controllers as the page of slide shown. And we don't have a component called controller manager. So we just pick them up from kube controller manager and install them into our API server. The third step, install OCM CRDs. I think no more explanation needed here. We need to manage the resource, so we install the CRD. Fourth step, apply resource like class role and class role binding for API server for preparing the running environment for OCM controllers. Fifth step, install OCM controllers. After doing the previous 2 steps, the registration controllers can be imported directly from the registration repo. We installed all the hub controllers in the registration repo to our control plane. The 6th step, install OCM webhooks. Just like the managed cluster mutating, managed cluster validating, and managed cluster set binding validating. Until now, we have done our work on the API server. And in the final step, ETCD. We use Embed ETCD, which will start a ETCD instance in our program, which means that we even don't need to install ETCD on our machine. And by the way, using existing ETCD is still optional. And after doing this, embed ETCD, all works are done. We've talked too much about building up the control plane. Now let's watch a demo video. In this demo, we will join a managed cluster to hub and apply work on it. First, we catch the make file. We just need to run make all to start the control plane. C is started. Let's move into a new terminal to interact with it. This is a kubeconfig file for control plane stored in .ocmconf/cert directory. Now we use a kubeconfig file to get API resources. We can see add-on, cluster, and work API groups. Now we initialize the control plane using modified class ADI. And we will use a canned cluster as the managed cluster. We will join it as cluster 1. Okay, the CSR is created. Let's check the managed cluster. Okay, now we can accept the managed cluster now. Till now, the join scenario is finished. Let's start to apply a manifest work on managed cluster. Here is our example manifest work. C is applied. And we will check about the pods on the managed cluster. The pod is created. Okay. Thanks for your attention. That's all. This is related links.
That was a great demo, Yucheng. I'm wondering when you start when you run that makefile, which version of the etcd or which version of Kubernetes API server is running? Do we define that, or is it all embedded into the standalone?
Hello. We've used the hello, can you hear me?
Yes, we can.
We use the ETCD version 3, and the embed ETCD is defaulted to the ETCD version 3. For the Kubernetes API server, I've used the latest version and modified it.
Thank you.
Thank you. I think that demo video is really great. I think we probably maybe could upload it to the YouTube or anywhere, and I will share with others that hadn't attended this meeting. I think someone is interested in running this, especially in the edge environment.
Yeah, I think that's a good idea. I will reach out to Yu Chang and grab the video and then upload it on YouTube.
Yeah, thank you.
Are there any other questions for Yu Chang? Okay, I think Yu Chang, if you could please share your screen and talk a little bit about the cluster API implementation that you have been working on. Thank you.
Okay, let me share. Can you see my screen now?
Yes, we can.
Okay. Yeah, so the background is that we got some questions in the community, especially in the Slack and also in the issue about what's the relationship between OCM and Cluster API and how is to work together. So in general, there are different things, like the Cluster API is more provisioning the cluster, maintaining the cluster, scaling up the clusters to multiple nodes, etc. But OCM is more on managing the cluster and updating the resource, managing the resources of the clusters after it is provisioned. So I did some tests on using the Cluster API and how that could work with OCM. So let me show a demo. So Cluster API itself has also very similar concept that it needs a cluster, Kubernetes cluster at first, as a management cluster to run the Cluster API control plane. So the first thing we need to do is to create a management plane. We can regard it as a hub cluster in OCM, but the Cluster API will need to run its own control plane in this cluster. So I start a client with some configuration so I can use it as a management cluster in the Cluster API. And to make it work, I still need to enable some features in the Cluster API. The first one is a cluster topology. Another one that I need to do is more on how we can integrate with OCM. Is I still also need another feature in the Cluster API called cluster resource set. The cluster resource set is basically a way that you can define some resources to be applied to the cluster that has been provisioned. So, and then after that, I can start a management plan using a cluster CTL. So I use infrastructure Docker. So it's just to create another kind cluster using the Cluster API. Okay, and then the managed plan has been provisioned, and we will need to create a cluster. The things I need to do is to generate a cluster. Its name is CAPI Quick Start. The version is 1.2.4, and this command will generate a YAML file to using the ClusterAPI resources. And then I will need to apply these resources into the management plan, that including the cluster class, machine template, and most important, the cluster resources that is going to create a cluster. So after that, we actually can see that cluster. Let me switch to no, let's first finish the demo script here. So after that, I can init the cluster EDM, init the OCM control plane on the same management plan, on the same management cluster. So we have this one, and with this one, we can try to do something like we can put this into for example, we can put this, but we can run it still in the hub, but we don't really generate this, really drawing a management cluster into the hub, but just run dry run, which will only output the YAML file that we should apply on the managed cluster. So this will give us, so I will just put all the join manifest into the test YAML, and then the next step is I create an import secret and put this test YAML into the secret, which is called import secret. So the type of the import secret must be add-on cluster kd-io resource set. So it's a resource set type secret. And the last step is I will create a resource set. The resource set will reference to the import secret. And then the class API will use the resource set to apply the things into the managed cluster. It's similar. It's somehow similar as a work API, but it is using different spec, and it cannot do a reconciliation. It's more like apply once way to just apply one time of the manifest to the cluster that is provisioned by the class API. So after that, all the things has been done, and I can go. So as you can see, is I have two clusters. One is current, one is the one that is provisioned by the class API. I can switch to the provision API, provision cluster, and let's see the clusterlet. So you can see that we have clusterlet running created in this by using the resource set, and we can see that the pod has been created, but because the worker node has not been started yet, so it still needs to wait some time until all these operators and other pod in our OCM component started later. So as you can see that the main thing that we need to do here is we need to define a resource set. resource set here, indicating that the resource set that I want to reference import secret. And within the import secret, it is actually, we put the test YAML. The test YAML just the output of the join command, like the CRDs deployment and something like the bootstrap secret in it. So yeah, I think that's all for my demo. I think one thing that I want to discuss is, since it's mainly depends on the resource set, we probably could like having a cluster ADM integration part to, for example, when we run the join command, we can see that we are using ClusterAPI, and it will help to create a resource set in the management cluster of the ClusterAPI. So it just gave us a better experience when we use ClusterAPI together with ClusterADM. So any comments and questions?
I think that was a great demo. We often get a lot of questions regarding Cluster API, and I think this is a good start so that we can have more tightly integration with Cluster API, because it is a popular project when it comes to multi-cluster related topics. When when a new user starts searching on Google, Cluster API frequently shows up. As regarding to the join command to integrate it with the Cluster API, I think that's a good idea too. But maybe it's more difficult. But is it possible that we go the other way, where we try to contribute towards Cluster API, and then we'll have some kind of like integration with Cluster API on their side, similar to how Cluster API have a bunch of providers like Azure, AWS, etc. Or is that too much right now?
Yeah, I think, but the provider is more like resource provider that provide the physical resources to provision the cluster. Our case is a little bit different. It's like when you after provisioning the cluster, how you can manage it. So yeah, I think that's a possible option as you mentioned. I will check whether there's any integration point in the cluster CTL. We can get in.
Yeah, because that's some feedback that we gotten. It'll be great if we have, we can do all the integration on our side, but our exposure is not as big as a project that have been there a while, the Cluster API. So I think it'll be great if we if we can have some type of integration on the integration projects, whether it's Cluster API or some other project. But yeah, I see what you mean with the providers. Generally, it's like the cloud providers that have these extra plugins.
Yeah.
Any other feedback for QGen? What about placement? Is there any way that we can tie placement into the cluster API as well? Or
yes, maybe with with resource set it is possible. Like in the resource set, currently it is it is like where I want to apply some resources defining a secret and config map with a label selector on the clusters. So we probably could do it with placement, like using placement to do the resource set. But that means we need some tightly integration with class API, like we for example converts the cluster resources in the class API to the managed cluster API in our case, etc. So
I see. And the managed cluster is not there yet until we have the the cluster left done. I see. Yeah. Just a fine.
Yeah, so I think one of the questions that we can think about is how, so I mean, the class API basically has a different area than a focus on the OCM, but considering there are different area, are there any possible way that we can integrate them more closely?
Yep. Any other comments for Qiuzhen regarding the cluster API? This community meeting. See you all next week or the next week. Take care, everyone.
Thank you. Bye.